Good day. This is our group presentation for assignment 2 from group 7, Zafirah Yaziyah binti Zainuddin, Muhammad Haris bin Muhammad Iqbalti, Naweli Chris Denny anak Ngali, Awangku Anur Wafi bin Awangku Gani, and Gibran Ivan Gide.
Hi everyone, my name is Naweli Krisdeni. I will be covering cost clarification and costing technique for Innotech HVAC project. First, cost clarification and behavior, we look at 5 costs given in the case: steel casing, assembly labor, factory rent, equipment maintenance, and electricity for testing labs. Steel casing and assembly labor are both variable costs. Steel casing is the direct material used to build the HVAC units, so the more units we produce, the more steel we need. This costs more. This cost move directly with production. Same with assembly labor, since workers are paid based on our work or unit assembly, so it also rises with output. Factory rent is different. It's fixed cost. No matter how many units Innotech produce, the rent for the factory stays the same every month. So this one doesn't change with production at all. We have equipment maintenance and electricity for the testing labs. These two are classified as semi-variable or mixed costs. For maintenance, there are routine schedule portion that's fixed, but if the production increase, the machine get used more, so there are extra wear and tear, which add a variable part on top. Same logic for electricity. They usually a basic fixed charge from the utility provider, but the more unit they test, the higher the usage charge get. So why does it matter? When Innotech expand, their variable costs are going to scale up directly with how much they produce. But fixed costs like rent will not increase just because output goes up, so they can assume total costs grow evenly. They need to plan based on which costs are fixed and which one moves with production. Moving on the costing technique. For HVAC unit production, we recommend job order costing. The reason is HVAC unit made for hospital and green buildings are all not identical. Each customer usually has different needs, like different cooling capacity, unit size, or special filtration requirement, especially for hospitals. Since each order is more customized rather than mass produced the same way every time, it may more sense to track the cost for each specific job individually instead of treating the whole production as one continuous process, which is what process costing is more suited for. Like in industry making identical large quantities such as cement or food production. With job order costing, Innotech can record material, labor, and overhead costs separately for each customer order. That way they know exactly how much each job actually costs instead of just estimate an average. To show how this works, we did a simple example. Let's say Innotech received an order for 50 customized unit for a hospital. Direct material, which is things like steel casing, come up with 80,000 ringgit. Direct labor for assembly is like 40,000 ringgit. Overhead is applied of a rate of 150% of direct labor cost, so that's 60,000 ringgit. Adding all of that together, the total job cost come out to 180,000 ringgit. Divide that by 50 units and we get the cost per unit of 3,600 ringgit. So Innotech can use this 3,600 ringgit as a baseline to set their selling price for this job, while still keeping each Other costs record separately since other jobs might have different specs and different costs.
Good day, my name is Awanku Anurofi, and today I am pleased to take you through our financial budgeting, forecasting, and operating planning for the upcoming quarter. To kick things off, let's look at our baseline operational cost and price benchmarks. We have fixed our unit selling price at 2,500 ringgits. Yet on the expense side, our unit variable cost, which encompasses our raw material, labor, and product testing, is set at 1,600 ringgit per unit. Additionally, our quarterly fixed costs stand at 450,000 ringgit, which translates to a steady allocation of 150,000 ringgit per month to cover factory rent and basic maintenance. Now, a key highlight for this upcoming quarter is our Q1 production and sales ramp-up strategy. We are intentionally taking a step-by-step approach to increasing production. This deliberate ramp-up is designed to ensure we smoothly integrate our new robotic welding automation without disrupting workflow or compromising quality. Because of this, you'll see our target volume steadily scale up month over month. Month 1, we aim for 180 units. Month 2, we scale up to 200 units. And month 3, we reach 220 units. This brings our total Q1 output target to 600 units. Moving on, let's look at how this operational ramp-up directly translates into our financial performance summary. As our sales volume climbs up from 180 to 220 units, our sales revenue grows from 450,000 ringgit in month 1 to 550,000 ringgit by month 3, pulling in a total Q1 revenue projection of 1.5 million ringgit. After factoring in our variable cost, which total 960,000 ringgit for the quarter, we generate a healthy contribution margin of 540,000 ringgit over the 3 months. Once we deduct our consistent monthly fixed factory rent of 150,000 ringgit, we can see a very telling trend in our net operating income. In month 1, our constraints are quite apparent due to the high initial capital allocation and lower capacity utilization. As we test the new robotics, our operational margins are tight, leaving us with a modest net income of 12,000 ringgit. However, look at the progress by month 3 as assembly line efficiencies stabilize and the automation hits its stride. Profitability climbs sharply by 300% to 48,000 ringgit for the month. This brings our total projected Q1 net operating income to 90,000 ringgit. This trajectory provides vital project validation. The fact that we are generating a positive net operating income right out of the gate proof the strong financial viability of this expansion, showing we can safely push well past our break-even baseline. Finally, let's analyze our break-even and profit planning to understand our safety threshold. Based on our benchmarks, our contribution margin per unit is calculated as selling price minus variable cost, which gives 900 ringgit per unit. This gives us a contribution margin ratio of 36%. Using these figures, we calculated our quarterly break-even threshold. To cover our total quarterly fixed cost of 450,000 ringgit, our break-even volume is exactly 500 units. In terms of financial milestone, this equates to 1.25 million ringgit. in sales revenue. If you direct your attention to the break-even analysis graph, you can visually see where these lines intersect. The horizontal blue line represents our fixed cost, and the orange line depicts our total cost. The green line tracks our rising revenue right at the 500 unit mark on the horizontal axis. The revenue line crosses the total cost line. Remember from our previous slide that our projected Q1 volume is 600 units because 600 units sits comfortably to the right of our 500 unit break-even point. It visually confirms why we finished the quarter in the green with 90,000 ringgit net profit. In conclusion, this plan demonstrates that our robotic automation investment is not only operationally sound but structurally set up for accelerating profitability as we move forward.
Hi, my name is Zafira Yazia binti Zainuddin. My metric number is PK221100362, and I'll be explaining about the capital investment and project evaluation. Let's take a look at the financial evaluation. The goals is to assess the financial viability of the automating HVAC casing welding. The machine costs for like 300,000 upfront, but it is expected to last for 5 years and bring in 90,000 in net savings every single year. These savings comes from reduced sheet steel waste, lower rework rates, and faster assembly labor. Our baseline hurdle rate for the project of this risk level is 10%. To prove whether this is a smart move, we calculated the net present value, which is the NPV, and internal rate of return, which is the IRR. Move on to the NPV. For 10% discount and for over 5 years, it comes down to 41,172. As for the IRR, between 15% discount and 16% discount, the linear interpolation calculation goes down to 15.24%. So it is above 10%. That's why the decision is to accept the project investment. Now, let's take a look at the inventory and cost control. As for the inventory, first of all, we have raw material, the components we buy but haven't touched yet, like sheet steel, copper piping, and high capacity compressor. Second is the work in process, known as WIP, the inventory currently trapped on our factor floor, such as steel castings sitting inside the welding base or system waiting for the lab test. Lastly, we have finished goods, the completed, verified HVAC units ready to ship out to the green buildings and hospital project. As for the cost control, mitigation strategies for WIP accumulation. To reduce WIP, we adopt a demand-driven for Kanban pull system. Second, we propose the line balancing and cellular layout. As for the enhancing inventory count accuracy, we recommended ABC cycle counting. Instead of stopping factory operation once a year for a massive count, we continuously audit high-value items like compressor weekly and bulk items like gasket quarterly. So pair with the RFID and sorry, barcode scanning, we will have a real-time visibility into our stock levels, totally eliminating supply shortage or over-ordering. That's all from me. Thank you.
Hello everyone, my name is Haris. Today I will be walking you through the critical frameworks we have developed for performance measurement and project cost management regarding Innotech's operational expansion. So let's start with our first slide. To ensure our new capital investments actually yield the expected financial returns, we need a robust way to measure performance. We are proposing 3 primary engineering related key performance indicators or KPIs. And this is to monitor the efficiency and quality of our high efficiency hatchback production line. So our first KPI is the manufacturing cost per unit. This is our total accumulated direct and overhead cost divided by total hatchback unit produced. And financially, this directly dictates our gross profit margin. By engineering better processes to reduce this cost, we expand the margin on our RM 2,500 ringgit selling price, which is directly accelerates the expansion project's return on investment. And second is equipment downtime. This measures how long critical manufacturing equipment, like our new robotic welders, is not operational due to unscheduled breakdowns. High downtime means we absorb fixed costs without generating sellable inventory. Minimizing this downtime maximizes our production volume, increases revenue, and ensures our capital equipment hit its projected annual savings. Last but not least, defect rate or first pass yield. This tracks the percentage of hatchback units that fail initially quality testing. Defective unit burn through variable costs like rework labor, through variable costs like and replacement steel casings. Lowering this defect rate eliminates wasteful expenditures, instantly increasing net profit and improving overall ROI. So moving on to the next slide, project cost management. Because this expansion involves significant capital investment, strict loss control is mandatory to prevent budget overruns. And to actively monitor costs, our engineering finance team will implement earned value management, or for short EVM. EVM is a quantitative technique that integrates project scope, schedule, and cost. It compares three key metrics, which is number one is planned value, our approved budget. Number two is actual cost, what we have actually spent. And number three is earned value, the quantified value of the physical work we have actually completed. So by calculating the cost and schedule performance indexes from these three variables, management can proactively identify whether the expansion project is over budget or falling behind schedule, allowing us to implement corrective actions immediately rather than waiting until the end of the quarter. To facilitate this EVM tracking, we will utilize two main tools. First, a centralized enterprise resource planning system to automatically compile real-time procurement, labor, and overhead costs as management dashboards like Microsoft Project to input our baseline budget and visually track our actual cumulative costs against our planning budget using Gantt chart. Thank you. That will covers our performance and cost management frameworks. Thank you.
Hello, my name is Jibran Abunjide and I will be presenting decision making tools part. We evaluated whether Innotech should produce HVAC compressor housing in-house or outsource it using two decision making tools. The first is the cost benefit analysis. Based on 2,400 units per year, in-house production costs 480,000 ringgit annually, while outsourcing only costs 410,000 ringgit, saving RM 2,000 per year. Over a 5-year horizon, total benefits reach 405,000 ringgit against cost of just 1,015 ringgit, giving a net benefit of 2,090 ringgit and a BCR of 3.52, meaning every 1 ringgit spent return is 3 ringgit 52 cents. The second tool is the decision tree with EMB. Outsourcing gives an EMB of 155,250 ringgit, while in-house gives 131,250 ringgit, a difference of 24,000 ringgit in favor of outsourcing. Both tools consistently lead to the same recommendation. Innotech should outsource compressor housing production for better financial return and operational efficiency.